Section 1.5, the power and sum difference rules. In this section, we are going to learn some of the shortcuts for finding the derivative. We will also learn a whole lot of notation, so you have to kind of keep track of all the notation. We already know that f apostrophe, that notation means the derivative. Now, depending on the context and depending on who's doing the work, whether you're in a business class or if you're doing economics or if you're doing accounting or if you're doing engineering, there's a different symbol for the derivative, but they all do the same thing. They're all the derivative. So on this section, I'm going to try to show you some of those symbols that people use to describe the derivative. The very first symbol that I'm going to describe is the dy over dx symbol. This means the derivative of the function that we call y with respect to x. So what does each one of those letters means? D stands for derivative. Y is the name of the function that you have in the problem. Now we say with respect to x because of the dx right there, and the purpose of that dx is to tell me that my problem has x's as the variable. So like for example, the y could be something like x cubed plus x squared. The letters in this problem are the letters x, and we want the derivative of them. Since the answer is going to have x's, we put dx on the denominator. Now, the command of doing the derivative is going to be described in a slightly different notation. To tell somebody to do the derivative, you just write dx, and then you put the stuff inside the parentheses. And this means that you're telling someone to find the derivative of the things that are coming next with respect to x, meaning you want the answer to be in terms of x. So there's a difference between writing dy over dx and writing dx like that. This means I am calling something the derivative. The result that I have is now the derivative. Whereas this notation means I'm about to do a derivative of whatever is written right next to it. So be careful to the different notations. People get confused over here in this notation section. And if you get confused with notation now, it's going to be very difficult for you to catch up later on. So make sure that we understand what's going on. Now, we are going to have a few different rules and shortcuts basically to find the derivative. And notice how each one of these rules is written down. It says d dx, meaning if you want the derivative with respect to x of the following thing, then you get the answer over here, right? This is saying if you want the derivative, then that's how you do it. So these are basically shortcuts. And the first one is known as the power rule. So this is going to be super important. It's actually one of the easiest rules that we learn in this semester, and it's going to be very, very useful for the rest of the semester. We will not go one section without using this rule, so please know it. The rule basically says if you want the derivative of some x with a power, so like if you want the derivative with an x and a number in the exponent, like a 3, then what do you have to do to get the derivative of this? One way to do it is to do the difference quotient. But that's going to take forever. And we did this problem earlier, and we saw how long it took. Now, this power rule basically says, really all you have to do is look at the n and place it in front of the quantity. So the n right now, the power is 3. Just write it in front. So slide your 3 from the power all the way to the front of the expression. Then write the letter x. Then subtract 1 from the power that was already there. The power that was already there is 3, just subtract 1 from that. And what do you get when you do this? It's just 3x squared. And that's it. That's the simple power rule, right? It's very simple, very straightforward. So let's try it again. If I have the derivative with respect to x of x to the power of 5. So this is saying, tell me the derivative of x5 with respect to x. In other terms, tell me the derivative of x5, but I want an answer to have x's at the end. The solution is going to be 5x, and then 5 minus 1 is going to be 4. So that is the derivative with respect to x of x to the power of 5. The next rule on the list is called the constant rule. And this basically says that the derivative with respect to x of any old constant, and by the word constant we mean any old number, so like 5, 7, -3, even fractions like 7 over 3. The derivative of any number with respect to x is always 0. So regardless of which number is sitting inside the parentheses, the derivative of that number is going to be 0. So even if you have derivative with respect to x of, let's say, pi, by the way is like 3.14, you'll get 0. What about the derivative with respect to x of -7/4? Again, 0. The derivative of a number all by itself is always going to be 0. Next up, we have what's called a constant multiple rule. This constant multiple rule basically says if you have a constant, meaning a number, being multiplied by some sort of a function. This is different than the last one because in the last one we just had the number all by itself. Right now we have a number times a function and we want the derivative. The rule is ignore the number and just do the derivative of the function. So how is that useful? Here's how. Let me give you an example. If I want the derivative with respect to x of, let's say, 5x cubed. According to this rule, we ignore the 5. So we just pull it out and we just ask for the derivative with respect to x of x cubed. That's how this rule is being used. So if you have a constant right next to an x, the constant gets ignored. It doesn't turn into 0, it just gets ignored and it gets written in front with a multiplication between it and the derivative. And by the way, the derivative of x cubed is going to be 3x squared. So this is going to be 5 times 3x squared, which turns out to be 15x squared, but you know, whatever. That's the rest of the problem. Okay? So that was the constant multiple rule. Okay? Now, finally, the last rule says derivatives don't care if you have a plus or minus. So again, if you have two x's being added or subtracted from each other and you want the derivative, you just do each one of them by itself using the power rule. So if, for example, if I have the derivative of x to the power of 3 minus x to the power of 2, then the rule says do the derivative of the x cubed, then do the derivative of the x squared, using the power rules obviously. Then, because there was a minus in the middle, just stick a minus in the middle of your two answers and you're basically finished. And obviously the derivative of x cubed is going to be 3x squared, the derivative of x squared is going to be 2x, and you're basically done. So that's what we call the sum or difference rule.